Hello, welcome back to topic 13, acids and bases. Today's topic is 13.1, properties of acids and bases, and our aim for today is to describe the characteristics of electrolytes, acids, bases, and salts. So electrolytes are substances that conduct an electric current. So this occurs when you have ions forming in water with mobile electrons, and this usually happens when you have acids, bases, and salts, which are all ionic compounds. So let's list some of the characteristics of acids, bases, and salt. Acids all start with hydrogen. So that's the first element listed in its compound, and they donate a proton and ionize in water, or H2O. Bases are metal bonded to a hydroxide, and they accept protons, and they also ionize in water. Salts are ionic compounds, which means you have a metal and a nonmetal, or a metal and a polyatomic ion from table E, and they ionize in water. So you can see all three of them ionize in water, which is what makes them electrolytes, allowing them to conduct electricity with mobile electrons available. So they depend on the concentration or number of ions in solution. So the greater the number of ions, the more electricity the electrolyte will conduct. The fewer the number of ions, the less electricity it will conduct. So non-electrolytes are usually covalent bonded compounds. They, except for acids, which all start with hydrogen, non-electrolytes have covalent bonds. They don't ionize in water, so they do not create ions to allow mobile electrons to be available. So sugars and alcohols are examples of non-electrolytes. And here's a couple of, this is your sugar and alcohol compound. Characteristic properties of acids. So they're acids that we come in contact with every single day. What do they taste like? Make sure you never drink something if you're not sure. So dilute solutions of acids have a sour taste. Dilute means it's been watered down. Some foods we eat contain acids, such as lemons, which have citric acid, vinegar, which is acetic acid, and carbonated drinks like soda, which contain carbonic acid. What do we know about acids when we put them into water? Okay, acids, when they're made into aqueous solutions, which means they're put into water, they conduct an electric current. Acids are electrolytes, and the higher the concentration of ions, the greater the electrical conductivity. So HCl, or hydrochloric acid, produces hydrogen ions and chlorine ions when placed into an aqueous solution with water, and that allows it to become an electrolyte. So let's look at table J for a minute. Acids react with certain metals to produce hydrogen gas. Metals above hydrogen on table J will react with acids to produce hydrogen gas and a salt. So examples, anything above hydrogen, such as magnesium and zinc, will react with acids and produce hydrogen gas and a salt. So zinc plus 2 hydrochloric acid, aqueous, produces H2 gas and zinc chloride. Okay, so you produce hydrogen gas and a salt, zinc chloride. So copper solid plus HCl produces what? So looking at table J, you can see that copper is beneath hydrogen, so you will not get this reaction. Okay, so here we would have no reaction. It doesn't occur spontaneously because it is below. So properties of bases. Acids have a sour taste. What taste do bases have? Bases have a bitter taste. So for some examples would be soap and toothpaste. What happens if you touch an everyday base? They tend to feel slippery or soapy. Examples, soap and bleach. And what do we know about bases when we put them into water? They also conduct an electric current. They are electrolytes. So the greater the number of ions, the greater the current. So sodium hydroxide will produce ions of sodium and hydroxide when placed into water. Acids react with bases to form water and a salt. So this is called neutralization. Water and salt form when you combine an acid and a base. So it neutralizes and produces water. Salt is an ionic substance with a positive ion and a negative ion. Remember, it's an ionic bond. So, for example, if you have hydrochloric acid plus sodium hydroxide, okay, we have an acid, begins with H, a base ends with OH, you end up with water and NaCl. So you end up with the H and the OH is your H2O, okay, and then your metal and nonmetal combine to form the salt. Okay, acid plus base produces water plus salt. This is an important reaction that you're responsible for knowing. And basically anything with hydrogen and X, meaning whatever is combined with hydrogen for your acid, plus metal with an OH produces H2O and a salt. Acids and bases cause acid-base indicators to change color. So table M has our common acid-base indicators. And here you can find what color changes will occur based on the reaction. So let's look in your reference tables. Where do we find our acids and bases? These are going to be located on tables K and L, and of course also the indicators that we just looked at on table M. So this is where you'll find some of your common acid and bases. Okay, so this is where we'll be looking. Which compound is an electrolyte? So let's remember our rule that it needs to be not something with covalent bonds. Okay, so this is covalent bonds, and this is an alcohol, no good. And this, if you look at your organic compounds and functional groups, this is an acid. It's an organic acid. From table R, your COOH ending. If you take a look at table R, is an organic acid. So number 4 here is an electrolyte because it's an acid. Which substance is classified as a salt? Remember, your rule is the salt has to be a metal and a non-metal. Okay, this is a base. We have a metal and OH. This is an alcohol ending in OH. Carbon and chlorine would be a covalent bond, 2 nonmetals. And here's our metal and nonmetal. An ionic bond would produce a salt. Here's a neutralization reaction. Which compound is a salt? Okay, so a salt again has to have a metal and a nonmetal. And our combination here is producing water. Notice this is H2O, and this must be the salt. Okay, if you have a acid beginning with a hydrogen and a base that ends with OH, you always produce water and a salt. This is the same as saying H2O here, and a salt. So K2SO4 would be our salt. And this is because this is a metal, and this is a polyatomic ion from table E. Sulfuric acid, or H2SO4, can be used to neutralize barium hydroxide. What is the formula of the salt produced by the neutralization? So we have H2SO4 combining with BaOH. So the hydroxide and the hydrogen are going to create the water. So the salt would be a combination of barium and sulfate. So BaSO4 would be our salt here. And that's the end of this section. See you next time.